Day 682 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1878. Get biggest three rhombus sums in a grid. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n integer matrix grid. A rhombus sum is the sum of the elements that form the border of a regular rhombus shape and grid. The rhombus must have the rhombus must have the shape of a square rotated 45 degrees with each of the corners centered in a grid cell. Below is an image of 4 valid rhombus shapes with the corresponding colored cells that should be included in each rhombus sum. Okay, so this is a picture. We have 4 different rhombuses right here. We have one, this blue one, this green one is the second, the third one is this red one, and then this fourth one is this little purple dot over here. It says, note that the rhombus can have an area of 0, which is depicted by the purple rhombus in the bottom right corner. Return the biggest 3 distinct rhombus sums in the grid in descending order. If there are less than 3 distinct values, return all of them. Okay, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our grid, which equals a 2D array of integers. Each one of these arrays inside this 2D array represents a row. So this would be the top row, 3, 4, 5, 1, 3. As you can see, the top row is 3, 4, 5, 1, 3. This would be the row underneath that, 3, 3, 4, 2, 3. 3, 3, 4, 2, 3. Then this would be the middle row, 20, 30, 240, 10, 20, 30, 240, 10, and so on and so on. So this would be the row right here, and this would be the row, the bottom row right here. Boom. The output is 228, or in this array of integers, 228, 216, and 211. So let's look at the explanation so we can see how they got this output from this input right here, and they give us this handy dandy visual representation so we can see what's going on. So it says the rhombus shapes for the 3 biggest distinct rhombus sums are depicted above. So the blue, this is the blue rhombus right here. Boom. So blue rhombus we get has a sum of 20 plus 3 plus 200 plus 5, right? 20 plus 3 plus 200 plus 5. Boom. So that's right here, that equals 228. That's where this 228 comes from. And remember, it needs to be sorted in descending order. Boom. So that's where this 228 comes from right here. Boom, we just add these together. Then the red is 200, 2, 10, and 4. So this red rhombus, we go 200, 2, 10, 4. When we add all those together, we get 216. So we can add that to our output as well. Boom. And then for the green, we get 5, 204, and 2, right? And that has a sum of 211. We can add that to our output right here. And these are the 3 biggest distinct rhombus sums that we can create in these, and we return them in descending order. So as you can see, we want to create the biggest sum or the largest sum possible, and for 3 rhombuses, right? We want to get 3 distinct rhombuses, and we want to return the biggest 3 distinct rhombuses. And this is an example of them right here. Boom. So just in case that didn't make sense, let's take a look at example 2 where there will it's a little tricky, right? So, or it tries to get a little tricky. So in example 2, we have our input grid equals a 2D array of integers. This is the top row, 1, 2, 3, 4, 5, 6, 7, 8, 9. So top row, middle row, bottom row. The output is 29 and 8. And the output is an array of integers, 20, 9, and 8. The explanation says the rhombus shapes for the 3 biggest distinct rhombus sums are depicted above. So for blue, we just go 4 plus 2 plus 6 plus 8. That's going to give us 20. Boom, that's where this 20 comes from. Now, this 9 just comes from right here. So it has this area of 0, like it says up here. Note that rhombus can have an area of 0, which is depicted by the purple rhombus here, right? So this has an area of 0. So when we come down here, we know this has an area of 0, but it still counts as a rhombus, and it's in cell 9. So we put 9 right here. Similarly with the green, I don't know if you can see it, but it's a little green rhombus right here in the 8th cell, right? And since it's in the 8th cell, that counts. We're going to add the 8 to our output as well, because this has an area of 0 as well, right? So in total, or in the final output is an array of integers 29, 8. First 20 comes from this 4 plus 2 plus 6 plus 8. The 9 comes from this little red rhombus right here, and the 8 comes from this little green rhombus right here. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, we have an input grid equals an array of integers 7, 7, 7. So as you can see, there's only one row, and all rows in that array are 7, and then the output is 7. It says all 3 possible rhombus sums are the same, so we return 7. So the only way we would be able to create a rhombus with one row would be if we put an rhombus with an area 0, similarly to how we did with these two, right? So, but excuse me, but no matter what cell we put the rhombus in, it's always going to be 7, so we could just put 7. Boom. So now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we're going to do is we need to get the number of rows in the grid. So we're going to come right here. We're just going to say let n equal grid.count. Boom. Then we're going to get the number of columns in the grid. So we're going to say let m equal grid square bracket 0. Come outside of that dot count. Boom. Then we need to use, we're going to use a set to store the unique rhombus sums. Using a set is going to avoid duplicate sums. So we'll declare a variable called sums, and we'll set that equal to a set less than sign and greater than sign, and put the parentheses. So it's going to be a set of integers. Boom. Now we're going to create a helper function that calculates the rhombus sums where x and y is the top vertex of the rhombus. So we're going to come up right here. We're going to say func calc, open up the parentheses. We're going to say underscore x colon, that's going to be an integer, comma, underscore y colon, that's going to be an integer as well. Come outside of that, and we'll open up the brackets. Now we're going to determine the maximum rhombus size that can be formed from this top vertex without going out of bounds. So y plus 1, that's going to be the distance to the left boundary. M minus y will be the distance to the right boundary. And then n minus x plus 1 divided by 2 will be the vertical space available downward. So we're going to say let max size equal min, min, open up the parentheses. So once again, we're going to say y plus 1, that's going to be the distance to the left boundary. Then we're going to say m minus y, comma, m minus y is going to be the distance to the right boundary. Then we're going to open up the parentheses, and we're going to say n minus x plus 1, come outside of this parentheses, and we're going to divide that by 2, and that's going to be the vertical space available downward. Now we need to iterate over all possible rhombus sizes. So we'll come underneath this, and we'll say for k and 0 dot dot less than max size. We'll open up the brackets, and if k is equal to 0, that means the rhombus is just a single cell. So we'll say if k equals 0, then we'll open up the brackets, and we'll say sums dot insert, open up the parentheses, say grid square bracket x, come outside of that, square bracket y. Then we'll come underneath this, and we'll say continue. Boom. Now come underneath this, and we're going to say we need to get the sum for the rhombus perimeter, so we need to store that somewhere. So we'll declare a variable called s, set that equal to 0. Then we'll start traversal from the top vertex. We'll say declare a variable called I, set that equal to x, and we'll declare a variable called j and set that equal to y. Boom. Now we need to traverse the first edge of the rhombus moving down left. So we'll come right here. We'll say 4 underscore and 0 dot dot less than k. We'll open up the brackets and we'll say s plus equals grid square bracket I. Come on, sorry, y'all. Square bracket I square bracket j. Come underneath that. We'll say I plus equals 1, and then we'll say j minus equals 1. Boom. Now we need to traverse the second edge moving down to the right. So once again, we'll come underneath this. We'll say 4 underscore and 0 dot dot less than k. We'll open up the brackets and we'll say s plus equals grid square bracket I square bracket j. Come underneath that and we'll say I minus equals 1. Sorry, y'all. And we'll say j plus equals 1. Boom. Now we're going to traverse the third edge moving up to the right. So this time we are going to come right here underneath this and we're going to say 4 underscore and 0 dot dot less than k. We're going to open up the brackets and we're going to say s plus equals grid square bracket I square bracket j. Come underneath that, we'll say I minus equals, oh, sorry y'all, this should be, both of these should be plus equals, so this should be a plus equals as well. And here we should say I minus equals 1, and then we can say j plus equals 1. Boom. Then we need to come underneath this and we need to traverse the fourth edge moving up to the left back towards the starting point. So we'll come underneath this and we'll say 4 underscore and 0 dot dot less than k. We'll open up the brackets. We'll say s plus equals grid square bracket I square bracket j. This time we're going to say I minus equals 1, j minus equals 1. Boom. Now we need to store this rhombus perimeter sum, so we'll come underneath this for loop and we'll say sum dot insert, open up the parentheses, passing s. Then we need to try every cell in the grid as the top vertex of the rhombus. So we come right here and we're going to say 4i in 0 dot dot less than k. Dot dot less than n. We're going to open up the brackets and we're going to say 4j and 0 dot dot less than m. Open up the brackets. We're going to say calc. Open up the parentheses, I comma passing I comma j. Boom. Now we need to sort the sum in descending order and take the largest 3 unique sums and convert the prefix result back into an array. So that means we got to come right here and we're going to say return sums dot sorted, open up the parentheses by colon greater than sign. Come outside of that, we're gonna say dot prefix, open up the parentheses 3 dot map. 3. Come outside of that, dot map, open up the square brackets, $0. Boom, y'all. Should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Cannot find sum. I think this should be sums with an S. So let's give it a run again. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 59 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom of the middle part. And this is the bottom of the code, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.